So yesterday we saw how to factor where a is equal to 1. Notice there was no number in front of my x squared. Today we're going to see how to factor when a is greater than 1. So I do have a coefficient in front of my x squared. Just like yesterday, first thing you need to do is write what's in front of the square twice. Notice I wrote a 3x and a 3x. Did I add the square here? No. So just anything in front of the square, write it. I wrote 3x twice. Again, this is called the no-fuss method. It's my preferred method of showing you how to factor because everybody can know how to write something twice. First step's pretty easy. Next, just like yesterday, we need to find a multiplied to number that also adds to another number. But it's a little bit different. The multiplied number yesterday, we looked at just the c value, the end. That's because what you're actually doing is you have to multiply the last by the first. Well, the first was 1. So any number times 1 is just going to be this number. Today, where that's a different number, we're going to have to multiply the ends. So this 3 times negative 5 is negative 15. I'm looking for two numbers that multiply to negative 15 and add to negative 2. So this part doesn't change. The middle number is still your add to number. But now, where a is greater than 1, you have to multiply that to the end, and that's your multiplied number. So two numbers that multiply to negative 15 and add to 2. First, like I said, let's start with the multiplying. Can anybody think of two numbers that multiply to 15? Let's say 3 and 5. Can these numbers add to a negative 2? Or subtract to a negative 2? How so? One of these has to be negative, right? Which one do you think would give me a negative 2?
Negative 5.
Very good. A negative 5. So, I believe this is the next slide. Negative 5 times 3 is negative 15. And negative 5 plus 3 is a negative 3. Sorry, that should be a negative 2. Typo. A negative 2. Our middle number. And then once you find that, negative 5 and 3, plug it right back into our empty spots, just like yesterday. So it looks like this, negative 5 and 3. Now we have one more step. Yesterday we were done, right? Once I plugged in, I'm done. One more step, go back and look. Is there anything to factor out? Does 3x and minus 5 have anything in common? No. Next one. Does 3x and 3 have anything in common? It has a 3, right? So I'm going to take out that 3, factor it out. 3 away from 3x is x. 3 divided by 3 is a 1. And now notice at the very beginning, I wrote 3x twice, right? I only have one 3. So I doubled up on my 3's when I didn't have to, which means you will expect to have to drop a 3 later, or divide by a 3, which happens here. Now you are done. After you drop this 3 that was unneeded, that you already doubled, now you have the final answer. So that's called the no-fuss method. That's the step-by-step basis. Let's look at this live. So, again, I have parentheses. I'm writing what's in front of my square twice. So what am I writing? A 5x and a 5x. Now I need to add some numbers in here. So I need my multiplied to. So multiplied to number, which is going to be what? 12 times 5, which is 60. So I need two numbers that multiply to 60 and add to what? 19. So let's go through the numbers here. Just give me any two numbers that multiply to 60. What's times 6 times 10? I think I heard. Will that add to 19? No. All right. We need something else. 5 and 12. So 12 and 5. Will that add to 19? Nope. 3? Like you should just start going through your calculator. 60 divided by 2 is what? 30, right? That won't work. 60 divided by 3 is 20? Will that work? No? Okay, what about 60 divided by 4? 15. So we have 15 and 4. Will that give me a 19? Hey, it took us a moment, but we found it. 15 and 4. So 15 times 4 is 60, 15 plus 4 is 19. What do I do with these two numbers? Yeah, they're the numbers that go right here. So plus 15 and a plus 4. Now I'm almost done. Yesterday we were done. Today, one more step. Anything to factor out? No. Anything to factor out? What can I factor out? I give you a hint. What number did I write twice? When I should have, at 5. So that's always going to be what you need to factor out. So if I take out a 5, that stays the same, 5x plus 4. Take away a 5 from 5x gives me an x, and 5 from 15 is a 3. Now I'm done after, again, of course, dropping that 5 out. This is why a lot of teachers don't like this method, because it's like, why did you just get rid of that 5? That doesn't work. That doesn't sound algebraic, but there is a proof that proves that this is sound. So my factor for this trinomial is 5x plus 4 times x plus 3. The no fuss. One more time. You guide me. What do I write? 2v, 2v, right? 2v and 2v. What's next? How do I fill in these holes? What's that? So I need to find my multiply 2 number, right? Put the 5 and the 2 together. 2 times 5 is 10. So multiply to 10. And then I need two numbers that also add to. Very good. Add to 11. This looks easier than the last one. What two numbers multiply to 10 and add to 11? Very good. 10 and 1, right? 10 times 1 is 10. 10 plus 1 is 11. So what do I do with these numbers? These magic numbers. Where do they go? In the parentheses, right? Put in a plus 10. And then put in my plus 1. Are we done?
No.
What's next? So anything to factor out here?
No.
So 2v plus 1. Anything to factor out here? What can you take out?
2.
A 2. So I'm going to factor out a 2. 2 take away 2v is just going to be a v, right? And then 2 from 10 is a 5. Now I am done. There's nothing to factor out of these terms here. 2v plus 1 have nothing in common. V and a 5 have nothing in common. I am done. That is the no fuss method. Like yesterday, but with some extra steps that hopefully aren't too bad. And it factors into that. Again, remember yesterday, you do have the option to check your work. So 2v times v, so I'm distributing here, is 2v squared. 2v, I also need to multiply it to 5, which is 10v. And now I'm multiplying 2v by everything over here. So let me look at the number 1, multiply that to v, which is just v. And then 1 times the other number 5 is 5. And when I combine my like terms, do I not get the original problem? 2v squared plus 10 plus v is 11v plus 5. I checked my work and my factor is correct.